Hi. So now let us see the main concept, whatever till now we discussed, that is the preparation for this concept only. So that is normalization. Okay. So this normalization is nothing if you understand functional dependency and its relevant concepts actually. That means simply whatever we done. Okay. So very easy manner, let us try to understand this normalization. So first of all, let us see some theory about this and then how many normal forms are there. Just broadly, let us have an idea and then one by one, let us get the clarity actually. So this is, for example, so this is actually, it is a process of organizing the data in the database. So if everything is there in the single table or two tables, when the database is big, then managing is not that much easy actually. So that is why to make the organization process is very easy, we can use the normalization process actually. Okay, that is one thing. And it is used to reduce the redundancy from the relation or set of relations. So redundant data easily you can identify and you can eliminate also so that you can save the space actually. Okay. And then it is used to eliminate many, very importantly, anomalies. That is, one is insertion anomaly, deletion anomaly, update anomaly. So these things we already seen clearly. What is insertion, deletion, and update anomalies? By doing normalization, automatically we are going to do, we are going to eliminate these anomalies actually. Those things we will understand in the process. And it divides the law. Of course, this is what actually going to happen. How you are able to, how these many applications are possible, this many advantages are possible is because it dividing the large relation into smaller relations actually. Of course, without missing or without creating extra duplicates. Okay. And you are linking those relations accordingly. So those things, all these things we will see in the discussion. So this is what just something about the normalization, what are all the benefits we are getting and how it is going to do. Now let us get the idea that how many normal forms we have, what are those actually. So if you see types of normal forms, the first one is first normal form. So very easy to remember, first normal form. In short, you can call as 1NF. And the second one is second normal form, 2NF. Then next, third normal form. Then the next one is bicode normal form. So this is BCNF in short, you can call. This is extension to third normal form actually, nothing is there. Okay. And of course, fourth normal form. And then we have fifth normal form. So here mainly what you have to understand is, so here just we are saying broadly, everything we are going to see clearly in separate lecture. But let us have in which cases you can say this is first normal form, second normal form, or BCNF, or fourth or fifth. So that is what simply we are going to note down here. Atomic values. That means you must have a single value. You must have a single value in every cell actually. If you take any relation or table, every cell must have only one value, at most one value. Sometimes it may be not. That's it. Second normal form, if you see, it must be first of all in 1NF. That is always. And then full every FD must be full functional dependency. As we discussed its definition already. Okay. There should not be any partial functional dependencies. That is also important. So how we will identify those things and how we will eliminate partial dependencies, how we will make them all as a full functional dependencies, we will see in the discussion. Then when it comes to the third normal form, very importantly, it must be second normal form and then no transitive FDs actually. So along with this, we have another thing that is actually, we can say transitive is nothing but this is what actually. Every X either super key, every FD if you consider, LHS part either super key or RHS part must be prime attribute. All those things we will see actually. Then bicode normal form, when it comes to bicode normal form, you can see determinant must be super key. That means if you take X to Y, X must be super key actually. That is what, only this one. This you are not going to allow. That is what bicode normal form. That is what we told, extension of third normal form is the bicode normal form. Okay. Then the next one is fourth normal form, no multi-valued dependence. So that also we will get the clarity. And the fifth one is no giant dependence. So all these normal forms are going to reduce these anomalies. Redundant data is going to reduce. So that ultimately it is a table. It is dividing actually. Okay, but always going too much in normalization is also not recommended, because it is increasing the complexity process actually. So that is why it's better up to bicode normal form is better actually. You don't need to go up to fourth or fifth. The only thing is if you have a so the only thing is if you need, then only go for the 4 or 5 actually. Okay. So once after understanding this, we will come back to this point especially, up to where it is recommended always, most of the times, and when you have to go for the fourth or fifth, we will see in the discussion. So this is what, first of all, I try to get the overall idea, what is normal form, what purpose we are doing this, and how many normal forms are there. Then in the coming lectures, let us see each normal form individually, elaborately. Okay.